Hello and welcome to Better Geology, and this is another installment in my ongoing series documenting my master's degree research and fieldwork process. I'm here on the first day of my second week of fieldwork here in the beautiful Strawberry Mountains with a new crew of willing and excited undergraduates to help me out. Holding the camera today is Lycan, and we got Kate and Kira from Vermont helping out with our very exciting research going on this week. Today we're kind of already at the end of the field research day. We hiked up a neighboring creek to find a most recent earthquake study site where I'm hoping to find things like charcoal and buried soils that will help us bracket the age of the most recent earthquake on the Strawberry Mountains fault. And just sort of in passing, I decided to check out this site right along the main road along Strawberry Creek where the fault scarp crosses the creek. There's an offset terrace here. The ground behind me is about a meter and a half higher than the ground where Lycan is standing holding the camera. And there's a very thin, gradual colluvial wedge here, which suggests to me that this is where the fault scarp crosses the bottom of the creek valley. So just kind of for fun, I decided to do an auger core here to see what the ground looks like and see sort of what the structure is. The sequence of soils between the colluvial wedge and whatever's below that. And I didn't really have very high expectations. I'd kind of put this site out of my mind, but since we had extra time today, I thought we'd check it out. And I found something surprising in that we found a buried soil. So a lot of this white material here, or you can bring the camera closer. Here, I'll bring up a new thing. So I'm bringing up a new auger here. You can see the GPS is recording the location of this particular core. And there's a root down there. Ugh. There we go. And some rocks. Most of this is a lot easier to dig through. So I pull up a new sample of material and I bang it out. So a lot of this darker brown material is, I believe, a buried soil, which has been buried by material, all of this white stuff from the uplifted terrace surface. A lot of this white material, I believe, could be volcanic ash, maybe from the cataclysmic eruption of Mount Mazama, which created Crater Lake. I don't have any evidence for that. It's just kind of a hunch I've got at this moment. But this dark brown material contains things like roots and gravel that we don't see elsewhere. And that suggests to me that this is, again, a buried soil preserved by all of this other material that preserves the age of the most recent earthquake on this fault. So if I do a little bit more exploration of this site in a future study week probably, I'll determine whether or not this is a good site for me to retrieve charcoal from. So I'm very excited, definitely surprised to find that this is as good of a site as it is. And if it ends up working out, you'll hear more about it in a future video. So here, Kira, Kate, and Lycan are at the earthquake history site, and this is a site where the fault scarp crosses a hill in such a way that it faces uphill, creating a little dam where sediment is trapped. And that creates an area that preserves stratigraphy, different soil units which can correlate to earthquake events. The dam that is created by this fault scarp has preserved about 5 different soil units, and we can find those with the auger core at depth and retrieve soil samples from them. And these soil samples, we then analyze them for color, for grain size, and any other identifying characteristics, and then we go through and try to find pieces of charcoal in them. And as I've mentioned before, these charcoal pieces are instrumental in determining the age of these different soil units, which allows us to bracket or estimate the age of the last earthquake. We actually found evidence for 2 earthquakes at this site, which is, of course, the whole point of this study is to figure out how often these earthquakes occur on this fault. So this is the morning of day 3, I think, out here in the Strawberry Mountains, and I am revisiting a moraine that you saw me video from on my last trip, that trip was mostly focused on locating large boulders to sample for helium-3 dating. And now this week we're collecting a lot of those samples. And an integral part of the sampling process is doing what is called, or finding the topographic shielding for a specific boulder. Now I'm standing on a big boulder here with plentiful pyroxene crystals, which is the primary target we're looking for. And its pyroxene crystals are what we use for helium-3 dating for this particular method. And this large boulder's full of them, so we're going to sample it. And in order to do that, we just take big chunks off. But before I do that, I'm going to figure out the topographic shielding, which is basically I'm at compass intervals measuring the skyline, and that tells us how much this location is shielded from the full hemisphere sky view of cosmic rays impacting the rock itself. And it goes a little bit like this. Kate here, my trusty field assistant, is going to record these specific measurements. All right, at 0 degrees north, we have a inclination. I'm using an inclinometer to measure the topographic height at different compass intervals. At 0 degrees north, it is 4 degrees. At 40 degrees, also 4. 80 degrees, also 4. At 120 degrees, 11. And there's a mountain peak over there, so I'm going to go out of my normal 40-degree interval just to get that high peak. It's located at 150 degrees. That's all the way up at 17. Next interval is 160, 12. 200, 11, 240. Actually, I'm going to get the valley. So the canyon up there is at 220, and that's really low. That's at 5. And then back to 240. Looks like 13. 280 degrees, 7. And lastly, 320 degrees, 7. So that information will be very useful in determining how shielded this particular boulder is from incoming cosmic rays, which is an important part of figuring out, modeling how long this boulder has been sitting here exposed to the sky. Up next, we're just going to take big chunks off of this rock and then continue down the length of this moraine, looking for more boulders and sampling from them. So we're here now at one of my sample boulders that I really liked for CRN dating. And one of the reasons I really liked it is because it looks probably undisturbed, and it's only about 4 or 5 meters from the crest of this heavily eroded glacial moraine, which means it probably hasn't moved very far since the glacier dropped it here however many thousands of years ago. This is going to be an excellent data point in figuring out the age of this moraine, which is, again, useful for understanding the broader glacial history and how that relates to movement along the Strawberry Fault. So in order to sample this boulder, I just take this hammer and this chisel and take some pieces off. All right, so it is now day 5, our final day up here in the Strawberry Mountains of this particular week of field work. And since we're up here at the end of the day, that means we have to pack all of these bags of rocks out of the wilderness. Each one feels, we estimate between 10 and 15 pounds of rocks, and we have 7 of those today between the 3 of us, so that's, it adds up quickly. And now that we're at the top of the moraine, we have to go all the way back down to the car. We might do 2 trips, but one of the joys of being a field geologist is getting your rocks out of the field. So now the only thing left to do is to pack up the rocks and bring them back home. And that is 1 of 7. Let's go. Time for another one. Oh, that's heavy. Ooh. Time to go. So here we are, about to cross the creek back to the car at the end of a very long day. This is actually the last day of this fieldwork session, so we're getting ready to pack up and head on home tomorrow. It's been a long trip, it's been a wonderful trip. We've had some interesting weather. Today we had scattered thunderstorms, but overall it's been very successful, and we look forward to digging into the data as soon as we can. This has been Better Geology with Andrew Dunning. Thank you very much for watching. You guys are funny.
I have that from the worst possible angle. Cheers.
The Strawberry Mountains.